So, hi everyone. Glad to join you all today in our new webinar after this hot summer break. And I'm glad to have Ian here with us, and he'll show us more of the goodies that they've been building in the trusted signing team, and things that we've been using for over a year now, and along with other folks in the private preview section, and now everybody can enjoy. So before I pass the torch to Ian, let me just give you like a quick agenda of what we're going to talk today. So first, Ian will tell us what trusted signing is, how much and what is Microsoft investing in this area. And then I will go on with some more details about smart app control and how that affects your packaging process and what you should pay attention when you will start releasing new versions of your applications on Windows 11. And of course, how we integrate the trusted signing in Advanced Installer and in all of our uh, continuous integration on all of our official integrations for Advanced Installer, for starting with GitHub Actions, Azure DevOps, and so on. So Ian, let's share the goodies with the folks now.
All right. So thank you again, Bogdan and Christina, for having me. I really appreciate this. Trusted signing is something that we've been developing over quite a few years, and it really has looked to provide value first when people think about code signing. And signing today, people think about the technical value of it being authenticity and integrity of anything that they're publishing. Now, most developers, though, will tell you the practical value really is in the reputation and trust that it provides, and avoiding messages such as smart screens messages of warning whether or not this downloaded executable or application installer should be trusted. And with smart app control, that goes a bit further, and we'll talk about that in more detail. But what we've heard over the many years of doing this is there's challenges in doing code signing as it stands today. It's difficult and expensive for developers, figuring out which certification authority to work with. How do I obtain those certs? How do I manage them? Then goes into the second challenge there. And there really is about the lifecycle management of certificates and the risks that are involved in that. It becomes very painful and costly. Then lastly, I have my cert. I now have to figure out how do I integrate it into my software supply chain and my build pipelines, and then apply signing appropriately and correctly. So I get the full value that code signing is meant to provide. Now, with trusted signing, we took all those challenges and we aimed to solve them with key features within inside of the service. Now, the service is fully managed, so there's really very little for the developers to have to think about and deal with when we talk about trusted certs. We provide all of the trusted certs that you need, all the types that you need are available within inside of the service. Those certs are coming from CAs that we own and operate, and they're Web Trust certified. They're also in the Microsoft Root certificate program. Then the certs themselves, customers don't have to actually manage them whatsoever, because the service provides a zero-touch certificate lifecycle management feature. So all the keys and certs are securely managed within inside of the service. You never have to really think about, oh, do I need to rotate my certificate, or when is my certificate rotation coming up? All those are gone. All the thoughts of, do I have to am I securely storing the private key and protecting the private key? The service does all that for you. Then we provide a seamless set of integrations that lead into the developer tool sets that are commonly used for signing today. Now, the service itself, we don't actually ask for any of the content that you're signing to be actually moved to the service or into the service backend to do signing. We're leveraging something called digest signing, which only is sending the hash needed to be signed. And that ends up being not only a confidential signing experience, but also a fast and reliable experience as well. Then with every cert that we issue and every cert that's used within inside of the service, we do active monitoring for misuse and abuse using Microsoft's threat intelligence pipelines and look for improper use so we can quickly detect, investigate, and take revocation actions as needed. So the building blocks of how this service is actually provided is all on Azure. This doesn't mean you have to run the service in Azure in any way. It doesn't mean you have to have build pipelines in Azure in any way. This is just where you're going to basically organize and manage your signing resources with inside of Azure. And these resources that we provide are all interconnected together. And I'll go into each one of these in detail here. So we'll start with the trusted signing account. So today, if you think about a trusted signing account, this is a logical container for all of your signing resources. Everything that you're going to do with signing, from your identity validation to the actual management of any certificates and the templates that equal certificates, are all managed within inside of the account. These accounts are available currently today across 6 different Azure regions. It doesn't mean that you need to be specifically in that region. So if you choose a US-based region or a North American region, your build nodes can be in Europe. But I would say you might want to use the Europe regions because that will actually reduce some of the latency between the service and your endpoints. The accounts and everything is all manageable via the Azure portal or through the Azure CLI experience as well. The service adds 2 new custom identities that are specific to the service, or 2 specific roles for the service, called the identity verifier and the profile signer, and they're not assigned by default. You specifically need to assign them, and we'll talk about where they're important. The other big factor here, a lot of times when I talk to people about what they're doing for code signing today, is they worry about, well, I have a cert, who's using it? I know I gave the cert or gave access to the cert to so-and-so on the team, or in this group, but I'm not sure how they're actually using it, what they've actually used it for. Our service actually provides you full log analytics and monitoring transactions capabilities there as well. So you get full telemetry of what's being signed and by what identity. So identity validations. Identity validation, think of this as, I'm going to prove who I say I am. As an individual, I prove that I'm Ian McMillan. As an organization, I may be representing Microsoft, and I prove Microsoft is a legal business and I am a legal representative of that business. So think about this as, I'm just proving who I say I am. And this is leading to what the values on the certificate will actually state in the subject name. For me individually, Ian McMillan. For the corporation, Microsoft Corporation. This identity validation, to be able to create one of these, this is where your first custom role comes into play. The tenant admin must assign this role specifically to an identity within inside of the tenant that allows you to create an identity validation. This way, not anybody within inside of the tenant can just create an identity validation. Only specific identities within inside of the Azure tenant is allowed to do that. Today, we support organizations, and individual identities are currently in a private preview state, and that will actually be coming into a public availability state in September. But like I said, it forms the basis of all your certificate subject name values. And then that validation needs to be refreshed every 2 years. Now, that's done automatically. So think about 60 days before your 2 years is coming up on an identity validation, the service will notify you through Azure that the identity validation needs to be refreshed. This just allows you to go into the identity validation, change or update any values that you need to, and then resubmit that identity validation, and you're able to refresh it. If nothing's changed, you can just click submit and move forward and get it revalidated. So for an organization, the typical things that we're going to be gathering here are organizational name, the web URL. We use a primary email address of the person who is doing the validation, and that's connecting that identity to the organization itself. And then the secondary email here is typically used for communications. So if the primary email address, let's say they're no longer with the company, or if they've moved on to a different role, the secondary email is also notified when things like an identity validation needs to be refreshed. We also ask then for business identifiers such as DUNS numbers, tax IDs, business numbers, the legal address of the organization, and that again forms the basis of that subject name that goes into a certificate. And you can see that you start to preview that at the bottom here. And lastly, we have you review and accept the terms of use for trusted signing at this point. For individuals, like I said, this you all use verified ID technology. And right now, what we're seeing in our private preview is about an estimated turnaround time around 5 minutes or so to get your individual identity verified. For organizations, it can take less than 24 hours. So for certificate, then once you have that identity validation, you're able to create a certificate profile. Certificate profile, think of this as a template for which all certificates are issued. Any certificate that is issued will have the same generic values of subject name. It'll be for public trust, let's say. It'll have current EKUs or extended key use values that are unique not only to your identity validation, but also will represent as being used for code signing. All the keys that are then generated and the certificates that are issued bound to those keys are stored within inside of the service that is all managed within inside of FIPS 140-2 level 3 operated HSMs. So we're meeting the hardware security module requirements for a service, and it's what we commonly use even for our own internal Microsoft signing services. Is we also use HSMs of that level as well. So we take private key protection very seriously in this. Now, certificates are automatically renewed daily. That means you have a new cert every day. You do not have to specify the new cert every day. The service is smart enough to know this is my most recent and active certificate. I'll use that one. Now, why do we do that? Well, it reduces your impact if there is a misuse or abuse case, or a case where I signed something that I didn't want to sign on a day, a specific day. I'm able to revoke that certificate for that day and not impact any of the other signatures that I've applied over months or weeks and or even years of doing signing. Where today with common certificates, those are issued and have a validity for a very, very long period of time. And they sign many, many pieces of software. And a compromise and a revocation action that follows has much broader impact on the code that you've signed. This allows you to be a much more targeted and surgical revocation action. Then with a certificate profile, we support 5 different certificate profile types. And these include public trust varieties, which is your standard publicly trusted code signing. We also supply a VBS enclaves signing certificate that is specific for a new piece of technology in Windows 10 and 11 that developers can use software-based enclave technology. Then we provide a test signing certificate, which is not publicly trusted anywhere. It's actually labeled with test only on them. And they're just great for using for inner loop build testing, things like that, where you don't want to put a production level cert. Maybe it's a dev's test build or something like that. You can use this for signing. Then we also supply options for private trust, which are really geared towards application control for business features in Windows, which was formerly known as Windows Defender application control signing. So think line of business app signing. capabilities there. And the CI policy signing that is associated to app control for business is also available there. Now, in order to do signing with any of these certificate profiles, to request the signature with any of these, you have to specifically assign the second custom role to identities with inside of your tenant to allow them to request signing. And that is the certificate profile signer role. Now, commonly, I'll always recommend that you use an Entra app registration instead of using somebody's specific account with inside of the, or identity with inside of the tenant. Like my identity inside of the tenant would be also being used to open emails and browse the web. So I am a prime phishing target, that identity, which if I become compromised, then I instantly get access. The attacker instantly gets access to doing signing. We don't want that. When you use something like an app registration, you're able to only use that with inside of the context of your specific build pipelines. And some of the demos that you'll see with GitHub and how you can use federated credentials allow you to really lock that down. So we always recommend using an Entra app registration. All right, so the integrations that we supply, specifically when we launched the service, was really, again, targeted at the commonly used signing tooling that we provide, or that Microsoft typically provides, and that starts with signtool.exe. Signtool.exe is the signing tool that's included in the Windows SDK, and we create a direct plugin for that. We also provide PowerShell modules for Authenticode signing and CI policy signing for that application control for business policy capability. And then we also then provide the trusted signing GitHub Actions experience and a Azure DevOps task experience. And what this just is straight signing. So when Bogdan and the advanced installer team said, hey, we would love to integrate trusted signing into packaging, it was like, that's going further, simplifying the signing experience for developers. So when you're packaging, you don't have to think, oh, did I sign my binaries before I package them? Oh, do I have to sign the package afterwards? Packaging tool such as Advanced Installer with this integration just does it. And it's really cool. I'm really excited about that capability. But let me quickly show you what then smart app control and unsigned binaries look like, and then signed binaries look like, before Bogdan gets into what specifically smart app control is and whatnot. So if I have and I'm using my daughter's laptop here. So my daughter is a high school student. She does all of her homework and things like that on this laptop. She also does all of her social media stuff and things like that she moves between her phone. She also does a little bit of gaming on this. But I've enabled all of the security features, including smart app control, which will target malicious or untrusted apps and block them. So if I just take an MSIX application that's unsigned and I try to install it, I'm unable to do it because it's not signed. Just period. It's not going to let me go any further. But let's say if I had a loose executable that was unsigned, would I be able to run that? No, smart app control is blocking that unsigned app because it doesn't know it, doesn't trust it. It doesn't know if it could be a new piece of malware that's never been seen before. So it's going to block it. What if I do self-signing? Now, self-signing is something where I can create a certificate locally. I can add it to my own personal machine here in my trust store, my certificate trust store, and say on this machine, trust this certificate for code signing. That will get me the ability to install my MSIX application. But as you'll see here, while I can install it, Smart App Control still blocks it from being run because the signature that's applied isn't publicly trusted, isn't trusted and known. It's only known on this PC, so this PC is protected further through Smart App Control. So even an attacker who creates self-signed certs locally, adds them to your trust store, and tries to execute their malware, can't. So what happens if we sign it with publicly trusted? This is where we now can see I can update that app and it's going to launch without any problem. This is the experience we want. This is what we're after. So Bogdan, why don't you go ahead and take over?
Thank you, Ian, for all the great details. So as Ian said, Smart App Control is a new security feature that probably many of you haven't encountered yet. It's built into new Windows 11 devices, and it's kind of a combination of Smart Screen and Defender. The way it works is that it runs on your Windows, and it checks to see if the Azure cloud systems has any intelligence, as Ian said, about the application, and can predict whether the application is safe or not. And it does that because, and this is where I'm assuming, maybe Ian can contradict me, some apps will not be signed, like you have famous open source applications and stuff like that, and you don't want those to be blocked on the machine. But in case there is no information about an application, let's say, for example, our team launched PacKit. It's a new desktop application we're building for IT pros. A few months ago, we launched the first version. That application had no reputation. It was never published online. It was only running on a few machines on our infrastructure. And the moment we signed that application with our trusted signing, with our trusted certificate from the trusted signing account, it just worked without any problem. So we had hundreds, thousands of installations. Nobody complained it was being blocked. Nobody said it couldn't download or install applications, unlike the problem that we've had in the past with regular code signing certificates. We can expect probably some false positives. I've had my fair share in the past. We'll see how this happens. And Ian and the team have learned a lot from the Defender cases. So his colleagues are ready to help us overcome these issues. I don't know if there are any updates or any specific plans for the Smart App Control, if there will be any submissions, specific submission processes, Ian, or it's something combined with the Defender processes on that side.
Yeah, so that process is still consistent with the Defender process and using the Defender submission portal, sample submission portal.
Yeah. So
that's how you get reputation.
What's important for folks to understand is that Smart App Control is designed to scan the application that you install on a clean machine. So if you have an older Windows 11 machine, chances are at the moment you won't get any of the Smart App Control benefits because it doesn't trust the current state of the machine. You might have that machine already contaminated with some malware or virus, so it's hard for it to understand. In the future, it will be able to do that even on machines that are not a fresh installation. But at the moment, it does it only on fresh new machines, and it does it only at the moment when you install the application. After you install it, then basically it's the Defender's the role to take over if something happens and the system gets corrupted. And now let's focus on how that affects the installers built with Advanced Installer or any other package that you're building and deploying as a desktop application. So I think we started preparations and tests last summer. I don't know exactly when it was a preview release of Smart App Control, because time flies. But the first thing that we hit was we had issues with open source components that we were introducing in Advanced Installer. And at the time, we weren't digitally signing those because we just never had that problem before. So, okay, we have some libraries from 7-zip and some other libraries that we were using for HTML rendering, I think, and something like that, or PDF generations. And we had to basically said, okay, if we trust that code and deploy it to our users, then we need to trust it to be able to put our digital certificate on it and make sure everything in that package is signed. And when we talk about everything in the package, with MSIs and EXE packages, there's another level of not complication, but I don't have a better word right now. Another type of resources that you need to have in mind on top of the binaries that you included. So in the demo that Ian showed you, there was an MSIX package that he was signing. In that MSIX package, you have only your binaries, the EXEs, DLL that you build from your solutions in Visual Studio. Inside an MSI, you will probably have some custom actions, predefined custom actions from Advanced Installer or from some other tool that is building that MSI. Maybe you write your own custom actions. And from the past, from my experience, I've seen rarely people signing their custom actions when they build them. Maybe you write a PowerShell scripts. That even happens even rarer to have that signed. So if you have this type of resources inside MSI and you try to deploy it without being signed, Smart App Control will start blocking them, and you will just probably see random crashes of the installer. Like, it's not fun to debug custom actions when you think everything should be working right and it's actually working on your machines, and people don't send you the log to understand. I don't even know what the verbose log of an MSI would write if it gets blocked by Smart App Control, but the simplest option for this is to make sure you enable signing in Advanced Installer, as I'll show you later in the demo. And we make sure that every custom action that you have included in the package, along with the ones that we include behind the scenes to automate stuff that come as a predefined functionality in Advanced Installer, gets signed. So all you have to do is to provide your certificate profile if you're using trusted signing, or your local certificate if your current one hasn't expired yet. And Smart App Control will recognize the identity of any of those certificates that you have, as long as it's a trusted public trusted certificate. Okay. And now let's have a look over the integrations that we've had with trusted signing in Advanced Install. So if you've been watching our releases in over the summer, you know that I think in April or May we've included the first integration of trusted signing in Advanced Installer itself in a desktop application. And we followed up on that with support for Visual Studio, GitHub Actions, and other integrations that we have. We have Azure DevOps, and I think we also have Bamboo and Jenkins, yes, for those. And the integration is very simple. It's all related to the Advanced Installer project that you initially create or you update in your machine, as you see in the demo. Prior to this integration, we had to manually configure some tools that Ian's team has building. So there's a new version of Sign tool and some libraries. You can get those via, I think you have some Nugget packages in Visual Studio for folks that use the Visual Studio extensions and basically don't use Advanced Installer in some other project, or maybe you use it in a different team that doesn't have a license. You get those from you can install those separate from a Nugget, but Advanced Installer also handles their installation automatically, so you don't have to worry about that. You just need to provide your some details about your certificate profile and the name of the certificate and the account name, and it will start working. But before I show you the demo how that works, I want to emphasize the security that Microsoft brings with this separation of management for the certificate. So up until last year, when we started using trusted signing, we had basically only one single person in the team owned the certificate for us. That was our lead engineer that was managing the release pipelines and everything. And even if there were cases where maybe me or another senior colleague needed something to be done, just out of caution, we tried to avoid get that certificate on multiple machines, because we wanted to make sure that we don't expose it to some external threats. And with the role-based access that Microsoft provides, you can also create, as Ian said, test certificates. You can separate access to those certificates. So, for example, myself and the colleagues from the team have access to the same Azure subscription, but only one of them has access to the public trusted certificate that we're using to sign Advanced Installer. And I'm using a test certificate. The QA team is using a test certificate, as Ian said, with a different profile. But this doesn't change anything in the configurations in Advanced Installer. It's one name of the certificate that you need to update for the project if you're signing the same project. And all the beauty is that Advanced Installer doesn't even handle the authentication with Azure. We just say, hey, sign tool, this is my certificate, this is my location, is it East Coast, West Coast, Europe, wherever you have it, and just sign me the files. And sign tool will see if you have the proper credentials on the machine, or if your GitHub action has the correct service principal configured, and take over from there. So let's have a quick look over the integrations that we've built into Advanced Installer, and we'll start with our Advanced Installer UI. So here I have a small project. It builds an MSI for a tool that we built, MSIX Troubleshooter, allows you to debug issues when installing packages. And this is an MSI build. As I said, we use it to also sign custom actions and everything that's included in MSI to avoid issues and incorrect detections from Smart App Control. And for those of you that know the application, you already know that you need to go to digital signature view and make sure you have enable signing configured, no matter the type of certificate you use. Here you have multiple options, and you'll find a new option. Let me zoom in a little bit. And okay. And you have here a new option that we say use trusted signing. And as you can see here, I'm specifying the endpoint where our region is hosted, the account name, and the name of the certificate. No credentials, nothing to be stored encrypted into the Advanced Installer project or anything else. My machine already has a session authenticated on the Azure cloud. You can authenticate via the Azure CLI or via your Visual Studio account login, or even an interactive browser session. You also have environment variables that you can configure, and basically sign tool does all the magic in the background to require authentication. So if I just trigger a rebuild here, in the case, as you'll see with the next integration Visual Studio, here I already have the binaries installed, generated. Advanced Installer takes those binaries, it inspects them and then prepares the CAB for the MSI, signs the resources, signs the final MSI. So it doesn't sign only the MSI that you generate or exe or MSIX, it also signs the files inside, as I said. And then it's off for testing or what's the next stage for your development team. So if we look at the MSI here, you can see that this is labeled as testing only, as Ian said. I don't want to play with my real certificate in the wild and get exposed. And this is like a very easy way to make sure that everybody's testing. So all the tests that our QA team has done over the last months, they've done with this certificate. I didn't have to worry about them running on their remote machines from home, or not respecting some installing something, I don't know, from a customer, because we get a lot of packages from customers and stuff like that. As long as we try to install everything in the VM, but you never know, mistakes always happen. So this way we ensure that the real certificates are always kept safe. So now, once you have configured this in Advanced Installer, oops, I just deleted the configuration, okay? You can add this project. This is an AIP project, and you can add this into an existing Visual Studio solution. So here I already added that, but if you're not, you just go and say, okay, I want to add a new project, and you search your Advanced Installer project once you install our extension, and you add a project file. And you'll see here we have a limited view for editing some of the most basic options of the package. You can see some contents of the package if you want to output an MSIX build and some basic details. For the full details, you can always go and say edit in Advanced Installer and use this option, which is a shortcut to our full UI. But you can do the same here, like configuring the trusted signing configuration, as we've done in the UI of Advanced Installer. So depending on the type of projects, we have cases where customers just spend all the time in Visual Studio and really open Advanced Installer, and vice versa. And then if you just build the project, Advanced Installer will run everything via our command line interface and process the packaging operation and signing, just as you've seen it in our UI. And this time it's even faster because it's not waiting on any UI notifications or updates. And now that you have your solution with your project set up, you can say, okay, now let's publish this into my repository, and let's have a look at the quick private test repository that I've made. So here, I've added this on my private account on GitHub. So it's the same project, Troubleshooter. We have the setup package and a few binaries. And I've configured for it a small GitHub action where we build a package in Advanced Installer. And we also sign it. But this time, I'm not actually logged in with my Azure account as I was on my local session on the machine. So here, as Ian said, we want to separate my full account, full Azure identity from the signing process. And I've just created a service principal. We've documented this on our website. There are a few articles on how to integrate and how to use code signing on your local machine and in GitHub Actions. And you also have more details on Microsoft website. And all you have to do is to configure these 3 secrets into your repository secrets area after you create the tenant in the service principal on your tenant. And once you've defined these secrets in the repositories, this is the same thing that you were writing before to build an MSI or an MSIX package that Advanced Installer, like 40 lines of code to get the package built. It checks out the package register Advanced Installer. If you have a look here, you basically see no information about what needs to be signed and how to be signed. That's all handled automatically by Advanced Installer. It just needs the authentication, so it knows to connect your GitHub resources with your Azure resources and make sure that the connection is the access to the resources is complete. So if we run this workflow, let's have it for a test here. It will take about a minute or so to build me a new MSI. Did I start it? Let's start. Okay, now it's starting. And basically, it's creating the entire image from scratch, getting the tools, and setting up the instance for a build while using the same test certificate that I used on my machine. But in this case, I just declared a service principal, and that service principal, it's just one line. Like I think it's this, yeah. One line in your Azure CLI command, specify the principal name and subscription ID for your tenant. Then, as Ian said, you need to change the role to add the role for trusted signing. It's called Trusted Signing Certificate Profile Signer. I don't know who gives those names, but it's especially designed to make it hard to remember. If it's something that's simple, it's long enough to make it harder, you know. Yeah. So
we have to use some kind of naming scheme, unfortunately.
Yeah, it's Azure is too big for there is no naming scheme that can make it up to it. So now you see it started building the project, and it's also signing the MSI, and everything got signed. Okay, so let's zoom in a little bit. You can see here, and now it's publishing an artifact. And if we go back and download that one, we should see the same signature on that package.
You want to go into the build,
Yeah, I
into
want
that
exactly
workflow,
here.
and it's right
Yeah,
at the
I
bottom.
want to get it here. So if we open this one, then let's go to my downloads folder, unzip it. And it should have the same signature that my test. Let me zoom one more time. I don't know if the screen is visible enough. Sharing session. So it's got the same test-only certificate that was used, but this time I wasn't authenticated with my account over that GitHub action session. It was just the service principal app that I declared. It was like 5 minutes things, just run that command line. You get 3 IDs that you need to define as secrets. You paste those on your repository and that's it. And you no longer have to worry about safekeeping your account. You should still safekeep it, but at least you don't lose access to the certificate or other precious resources in this example. And these are basically the things that we can do with only $9.99 a month. So it's like, and you don't have to worry about renewals because the moment when you were talking about how easy it is to add the identity validation. I just remember the moment we signed up last year. So I'm an admin in our Azure tenant. So I just said, hey, Catalin, one of our founders, I'm going to add you as an identity validation. He just submitted some, I think some scans of his ID and some registration paper of the company. And the next day I just went on with my work, and it was such a painless experience compared to the previous years of renewing a certificate, or exactly even renewing certificates from existing vendors was even harder than that. And then the build times were actually unsurprisingly very. I don't think we ever had a problem in the last 14 months or so with the build times. Maybe you've stress tested a little bit more on your side, but at least from we have just a few million lines of code and not such a big application as Windows itself it is, but it was never a problem in our daily builds, not only the monthly releases, because we use it to sign at least a few builds every day for the testing team. And it's always worked flawlessly.
Yeah, and that's great to hear. I mean, so right now we see about 2 million signatures per day on the service. Now that's small number in comparison to what we do for our internal instance for Microsoft signings. Where we see across all Microsoft product and services over 400, 500 million per day.
And you're sending that bill to Satya, or who's
We're signing every build of Windows, Office, Azure, to the firmware. We say we're signing chip to cloud in our internal services, and we want to enable people on trusted signing in this instance to be able to do the same. Right now, we're starting with the Authenticode and Windows app signing, but we're quickly going to be expanding to support container image signing, to supply chain data, Linux signing, common GPG capabilities is also on our roadmap, and so on and so forth. The latency targets that we're seeing are on average is about 500 milliseconds per signing. And we'll continue to work on optimizing that and making that faster and faster as we.
Yeah, that's the only thing so we did notice like a little bit more time on signing, but for us that's not a problem. A few minutes on a build that already takes half an hour, it's not a problem. It depends. If you need to have a build every 5 seconds, maybe then you need to host your own HSM and get it FIPS certified, and you'll see if it's worth it. But for regular developers like us, I think it's more than perfect. So let's have a look over the Q&A questions. I see that you and my colleagues answered most of them, but maybe it's worth repeating some of them for the folks that will listen this recording afterwards. Okay, so do you have any preferred ones that you want, or I can just pick?
Just go ahead and pick. Yeah.
Okay, so the first one is from Rory. It says, "Will this work with MSIX?" And of course, it does. It works. It's working right now. It's not the MSIX packages that Ian the demoed earlier was signed with Azure Trusted Signing, and it will also work with V6 packages very soon, which we are also eager to sign. We are actually testing right now. For that, you need a newer tool from Ian's team that will be releasing soon. But basically, mostly any binary that you usually build on a Windows machine and deploy can be signed with. It's just a regular code signing certificate, but you don't store it on your machine. It's stored and managed by the cloud in Azure.
Yep. And to add to that, specifically, Bogdan, what you're referring to is the open source .NET sign project, which the community currently, we work with the community of open source developers there to integrate trusted signing. So you can do NuGet signing as well as Visix, and Click Once is still being worked out through that tooling, but you can do Visix right now and NuGet packages, as well as your normal Authenticode signing as well with that tool. But it's still, I love the fact that you can package your app and the packaging does the signing for you. Because one of the biggest challenges, even internally at Microsoft over the decades that we've been working with product and service teams, is when they're trying to determine what do I need to sign before I package, is people miss things like their uninstaller. It was the most common one.
Just as the problem we help Dirk solve when he recreated the package for Image Magic. So when image signing, when trusted signing was released, one popular open source application, Image Magic, decided to create their MSIX packages with advanced installer. Those packages, I think, were created in the past with a Visual Studio extension from Microsoft. But the problem was that Dirk had to get the MSIX, extract the contents from the package, sign them, and then package the MSIX back. So it was just wasting computing cycles and basically complicating his work, because he had to know what's inside the MSIX, how to extract it, how to put it back, when that shouldn't be his worry at all. So when he replaced that extension with our Visual Studio extension, and he said, okay, I want to build an MSIX, he configured that into Advanced Installer project. Then Advanced Installer got the output from the project added in that solution, and signed the binaries before it got included inside the MSIX package. So basically it saved the 2 or 3 steps and simplified the entire YAML. I think it reduced it by half or so.
Yeah,
I don't know. You don't want to reinvent the wheel and extract MSIX packages by hand and put them back together.
Yeah, which we see people doing a lot, and it's not typically always necessary, but I would always say it's best to sign every binary that you possibly can sign, because that not only is a great signal to any kind of security feature or product that's trying to protect end user systems, it's also really a protection of, this is what I published. If it was tainted in any way by anybody from the time that I released it, that signature is broken. So it's really, when you look at it from that perspective, it's protecting not only your publisher name, really, and your integrity as well of what you're shipping.
So I see 2 more quick questions here. So one is about the pricing, which is favorite one, because I get the joy to tell people how affordable it is. And even if you're a big company, like we are 50 people here, and usually that the pricing shouldn't be a problem. It's still a joy to see that it basically costs us nothing to sign this. We to sign Advanced Installer for all our releases and anything we do, we just pay $100 each year. So like $9 a month, And the joy is, I think, that if you're registered as a Microsoft partner, Action Pack partner, or some other levels of partnership that you have, I think you have some Azure credits there, and you can sign against those. So I know we've used those in the past, and probably we still use them. And maybe they're just unused in your account. So it's basically free signing and free management for your certificate. And another important question, which I think you can give more details Ian, is if we have an existing certificate, can we import that or not?
Yeah, and that is a no. So with publicly trusted code signing certificates in particular, the requirements are set out by the CA browser forum that is no importation or exportation of private keys and certificates. So that means the certs that you use inside of a signing service must always reside in that signing service. Now, with our service, you don't need to bring your own cert because we provide you the certs. It's part of the service. We don't charge you extra to buy a cert from us or anything like that. It's just part of your standard account. It comes with it. And you can get all the different varieties of certs, access to all of the certs. So you can create a test cert, publicly trusted cert, a VBS enclave, public trust cert. When we add document signing, you can add document signing cert, so on and so forth. And it still just costs you the flat account fee. It's no extra upcharge for that whatsoever. We want to make code signing and signing something that everyone can do affordably without trying to figure out how do I manage the cost of having all these different certs and using the appropriate thing. Now you're just going, okay, I need this cert. Let me use that one. I need this cert for test. Let me use that one. You're not thinking about the costs necessarily associated for those.
Yeah, if you have an USB token, I strongly recommend to move to trusted signing or some other solution for cloud signing if you don't use Azure at all. Because I've seen cases where people say, okay, I don't want to create an Azure subscription. Even practically subscription is free if you don't use any resources. But if you don't want to use that, I think the guys from DigiCert, they've also created a cloud offering on that side. Probably others will be starting to.
SSL.com, I believe, is also set up one, as well as SignPath is also out there.
And the idea is here that you want to rely on a cloud service to manage the authentication and the certificate, and not to try to work around an USB token that was designed to require for authentication every time you plug it in. So the question we've had countless time on support was people saying, hey, I'm plugging in the USB token and it asks me for the PIN. How can I automate that? And we try to always tell that's the point, not to be automated. That's making it secure and making sure that somebody doesn't sign without your permission, like an automated malware running on your machine over the night or something else. And it would be a serious security flaw if the providers of those tokens would allow you to automate it. Yeah, you can probably find some workaround and write some tools that click on your screen or something like that, but we highly recommend against that. So, and you still have to renew the certificates and manage the token. I don't see the added value unless you're in some offline environment, and you need that kind of security where you carry the USB token on your next to your keys. You don't need anything else than something like that, especially if you want to do it in a cloud. If you want to build your project in using GitHub Actions, Azure DevOps, or some other solutions of hosted cloud builders, good luck doing it with an USB token, because I don't know how to do that. You can't do a prompt. I assume they don't have a command line to pass that, because that's too long. So there's no option to do that. So I think this sums it up for today. If folks have more questions, they should visit the aka.ms/trusted signing, and you can find there all the details that Ian and his team has been working on. And you can also find more details on advancedinstaller.com/trusted signing integration, on how it integrates with Advanced Installer and how you can use it on your GitHub Actions and Visual Studio and all that details. And if you have more questions, just email us at support@advancedinstaller.com or just hunt me or Ian on LinkedIn and Twitter. Thank you all.
Absolutely.
Thank you, Ian, for joining us.
Oh, thank you again for having me. This is great. And I hope people find this useful and can sign all their code. And just quickly, I see questions here about if your signing account lapses, will my signatures continue to be validated? Signatures that are timestamped, and we provide a timestamping endpoint, are good forever unless the certificates are specifically revoked. So even if your account has lapsed or you no longer have an account, the signatures you produced will continue to work just fine.
Timestamping is crucial. Thank you, Ian. Thank you, everyone.
Thank you.
Bye-bye.